Hello students, welcome back. I am teaching you a course on circuits and systems. In today's lecture, we will study the response of a continuous time LTI system and its convolution integral. Well, in the previous lecture, we have seen the linear time system and the time invariant system. We saw a system is linear if it follows two properties, and these two properties were the additive properties and the homogeneity. Homogeneity. Additive says if you have signal x of t, its response is y of t. So you can say y1 of t is the response of the signal of the system when xt is applied to it. Y2t is suppose the response of the system when another signal x2t is applied. So then additive property says that I can combine these two. Y1 of t plus y of t is nothing but the response of the system to the signals x1t plus x2 of t. The homogeneity property says that if y1t is the response of x1t, if y1t is the response of the system to an excitation x of t, then a times of y1t will be the response of the system if the input was also scaled by the same factor a x1 of t. Now, a system, this is linearity, a system was time invariant if a signal response of the system to a signal x of t minus t, it will lead to a time invariant response as y of t minus t. Then what is a system? That is a LTI, which is nothing but a linear and time invariant. So this LTI system is linear as well as it is time invariant. So the response of such a system, as we studied in the previous class, was that if the arbitrary signal, any arbitrary signal x of t was applied to a LTI system, then we know the output is nothing but of a LTI system. The output is nothing but the output is nothing but y of t is equal to some action on this signal, that is x of t, and this turns out to be a transformation on the convolution of these two signals. So I can express this as from minus infinity to plus infinity of x of tau into del of t minus tau and d tau. So I can take this operator inside and say what is this equal to? this is equal to minus infinity to plus infinity of x of tau into transformation on the signal del of t minus tau and d tau. So looking back into the time invariant property, so the response to this signal will be, now the response of the system, for for a time invariant system, since for time invariant system, we know that h, the response of this system will be h of t minus tau is equal to the operation on this signal, that is del of t minus tau. Now putting this value back into this equation, so therefore what do you have? The equation y of t is nothing but equal to minus infinity to plus infinity of x of tau into h of t minus tau into d tau. So this is the solution to the signal, an arbitrary signal xt when applied to an LTI system. Now, what is the convolution integral? Convolution integral. Sometimes, sometimes we can write this equation also, or we can also write this as equal to minus infinity to plus infinity of h tau into x of t minus tau d tau. And this operation is nothing but the convolution operation. So we can express this as the convolution of x of n or x of t, in this case convolve, this is a convolution operator on h of t. Now what is this convolution integral? So we know that y of t is nothing but this convolution integral. I can write this as, so x of t into h. It is not a multiplication. It is not a multiplication, but it is a convolution operation of h t and xt, where xt is some arbitrary signal, and this is nothing but equal to this. So I can substitute this value is equal to, which is nothing but minus infinity to plus infinity of x of tau into h of t minus tau into d tau. So this is commonly called as a convolution integral. So let me mark this with a highlighter. So this equation is nothing but the convolution integral. So I will write this as equal to y of t. And this is the convolution integral. So thus we have the fundamental result that the output of any continuous time LTI system is the convolution of the input xt with the, so let me write down, this is an important statement. So let me highlight this. So this particular equation, which is commonly called as a convolution integral. So thus we have a fundamental result. What is that? That the result is output of any continuous time, LTI system, LTI system is the convolution of xt, convolution of the input signal x of t with the impulse response of the system. impulse response of the system. That means what did you have? If you say this is my LTI system, this is my LTI system, and you applied an impulse del of t, for this the response was h of t. But if you give any arbitrary signal x of t, your y of t is nothing but the convolution, which is nothing but equal to x of t convolved with h of t. Now, since we are talking about the convolution integral, we can see that convolution integral has the following properties. So, the properties of the convolution integral, this is one of the most important topic, properties of convolution integral. There are three properties associated with the convolution integral. So, first one is the commutative property. So what does it suggest? It says the convolution, if there are two signals which are convolution of each other, xt convolve with the h of t, as per the commutative property, so we can write this as h of t convolved with x of t. This is the first property. The second property is the associative property. So this associative property says the convolution of x of t with the h1 of t convolved with the h2t, this will be equal to, we can, by the associative property, we can also say that this is xt convolved with h1t convolved with h2t. The third property is the distributive property. The third one is the distributive property. We know what the distributive property is. So if you have summation of two signals convolved with the third signal, that means if you have x of t convolved with the h1t plus h2t, so the solution will be equal to a distributive property. So this will be x of t convolved with the h1 of t plus x of t and convolved with h2 of t. So, well, fine. In this lecture, we started with the what a linear system is, what a time invariant system is. Combining these two, we form a system that is called as a linear time invariant system. Then we saw what is the response of the LTI system. The LTI system response is nothing but the convolution of the impulse and the some arbitrary signal that is inputted, which is equal to integral from minus infinity to plus infinity of h tau, ht minus tau, d tau. So there are three properties of the convolution integral. So these three properties are: one, the commutative property; two, the associative property; three, the distributive property. So these are most important for your examination. You just re-listen this video and try to make a note on your notebooks. Thank you for watching this video.